Okay, grade 12. So let's look at the exponential laws and how to apply them. You've done this in grade 11, so this will be a quick overview. So I'm just going to write down the laws and talk to it. So first law, to remember that the moment when the bases are the same and they are being multiplied with each other, you can add the exponents together. With the second law is when the bases are the same and it's being divided, then you can calculate this by subtracting the exponents. Then the third law is if you have a number, unknown number to the power of n to the power of n. You can basically multiply the two exponents with each other in your calculation. And it will always help just to give you a quick example of this or how to understand this. For instance, if you have a question like this, x to the power of 2 to the power of 3, what we have there is x squared times x squared times x squared. Now if we apply the first law in this case, we know this will be x to the power of 2 plus 2 plus 2, which is equal to x to the power of 6. If you multiply 2 and 3 with each other, it becomes 6. So just to help you see that, it really helps. Yeah. Okay, so the fourth law, or just the fourth one on the list, it's really not, they're not numbered in a specific order, is the moment you have an exponent in this format. This exponent will be applied to both as long as it's a single term. So this can be multiplied, it can be divided. As long as it's a single term, this will happen. A to the power of n times b to the power of n. The next one to consider is, well, remember this goes in the opposite direction. All of these laws goes in both directions. Next one just to consider is this x to the power of negative n is equal to 1 over x to the power of n. And again, this is applied in both directions. Then the last one I'd like to look at is anything to the power of 0 equals 1. So this is a quick breakdown of the different laws, and now I'm going to do one or two questions just to show you the application of these laws. Before we continue, it's worth mentioning the following. Let's say you have that type of expression, a to the power of m to the nth root. This is equal to a to the power of m divided by n. As an example, square root of x. Remember, if there's no number written there, it's automatically a 2. This is equal to x to the power of a half. So just remember that. Okay, now we're going to go into the examples. Okay, so the first example is, you can see there, whenever you have exponents as decimals, it's always advisable to write them down as fraction. And if you have something like 1.5 and 2.75, which is a mixed number, which will end up as a mixed number, write it as an improper fraction. It will help you tremendously. Remember, this exponent does not apply to the 3, it only applies to the x. Same over here, 0.25 only applies to x, not to 4. So we can actually start off by saying, okay, this is a single term, and I can multiply 3 with 4, and we can write it down as 12. Then x, 2.75, if you make it an improper fraction, is to the power of 11 over 4. Y is 3 over 2. And x then is 1 over 4. And y's exponent is negative a half. Okay, so we have 12 times x to the power of, remember we've got multiplication now, so on the same basis, so the only thing we need to do is to add the exponents together. So you have 11 over 4 plus 1 over 4 times y. We've got 3 over 2 minus a half. Okay, next step will be to simplify. So 11 plus 1 is 12, so 12 over 4 is 3. So it's x to the power of 3. And 3 over 2 minus a half, so it's 1.5 minus a half is 1. So this is our final answer. Okay, so the next example looks like this. So we're going a little bit more complex, but if you really look at it, it's not more difficult than the previous one. It's really the same. Something to notice, this as it's written down here is a single term. We've got a third root there, a third root there, technically a third root there as well. And let's look at what's underneath the square root. So this is a trinomial. We can factorize this and it will become x minus y in the bracket square. So that would be my very first step. I will write it down, x minus y in the bracket square. And remember, the third root. You can see that out of habit, I always change square roots, third roots, whatever root there is, to an exponent. Because we're working with exponents, it's much easier to see what needs to happen next. So over here we have a third root as well. X squared minus y squared is the difference between squares. So as a denominator we've got x minus y in the bracket times x plus y, and all of it to the power of a third. So the exponents, all of them to the power of a third. So we can rewrite this as follows. X minus y in the bracket squared times x plus y divided by x minus y times x plus y, all of it to the power of a third. Now we can cancel out what can be cancelled. Those two can cancel out. This one will cancel out with one of those. So we will be left with a final answer of x minus y to the power of a third. Okay, the last example we're going to look at is example 3. And it has a lot of square roots again. First things first is notice that we have one single term. There's some multiplication right in the middle. And this is to the power of a half to the power of a half. So we can rewrite this as follows. We can say 5 minus 2, which is 3. It's not needed to write it as a 3 yet, but we do remember that was it. It's to the power of a half to the power of a half times 27 to the power of a half to the power of a half. Next step is to simplify. A half times a half is a quarter, so it's 3 to the power of 1 over 4 times 27 to the power of 1 over 4. And we notice there we've got the same exponent, so we can apply our laws and say this is 3 times 27 to the power of 1 over 4. And then from there on, 3 times 27 is 81. So let's double check. So that's 81 to the power of 1 over 4. And that is equal to 3. And that brings an end to our exponential laws and how to apply them.